Hello guys, welcome back. In this video, what we are going to understood? We are going to understood how to fine tune any general ML model or any general LLM model with very less number of parameters. So that we will understood in this video. Now I want to find a model and then I want to fine tune it. How can I able to find a model? So do I have any LLM model providers available? Yes, we have LLM model provider. That is the famous multiple LLM model providers are there. Among Hugging Face is the famous one. So that's why I'm opening this Hugging Face community. In this, you can observe I'm opening these models tab to see what are the famous models I have. You can see approximately exactly 1,154,534 models are there. Among these, so what model I want? You can choose based on your specific use case and based on your specific requirements. You can even choose the model based on the parameters that you have. Currently, for my purpose, I want to fine tune a model. So in order to show you generalized way, I'm taking this GP2 model. I want to take a GP2 model. You can see this is the OpenAI community based GP2 model. Now I want to take it and I want to fine tune it. So what it will do, if you click on compute, here you can see for the given text, it is again generating you some more text, right? Yes. So that's what it is doing. Now let's understood how to fine tune this model. Let's understood how to fine tune this model. First, we will pick this model and then we will take some random data or some random text file data to fine tune this model. For this, I opened this PyCharm platform. Here, I want to first task. What is my first task? I want to pick a model. Pick a model. Then just I want to fine tune a model, right? Yes. So now let's understood how to pick a model. For picking a model or for taking a model or for loading a model, we have two ways. If you open this, that is the provider, LLM model provider. Here, use this model option is there. Under that, libraries option and transformers option is there. Here you can see this is one way to load, or this is one way to use the model, and this is another way to use the load the model. Since I want to train my model, we need to load the model. You can see these are the commands that we need to use to load the model. Now I'm writing the commands for that. In order to load the model, we need to provide or we need to specify the exact model name. What is the model name? Model name. In this variable, I want to store the model name. So for this, I want to copy the exact model name from the provider. That is this. I just copied. Now, yeah, I'm just storing that model name in this variable. Now, so first I want to load my model, right? Yes. So how can I able to load my model? We need to load our model by using auto model for casual language model. From this, we need to load our model where this library is present. While loading, you need to use this function dot from pre-trained of this model name you need to provide. Like this, actually, we need to load our model. In order to load our model, we need this auto model for casual LLM, casual language model, right? Yes. So from where I get this? We need to get this from transformers. From transformers library, we need to get it. I've already imported this transformers, so that's why I'm not getting. If you have not imported this, then just write pip install transformers and just click on enter. Similar to this, you also need to install the torch library because it's a dependency of it. Okay. Now we loaded our model. With our model, we need to load a tokenizer as well. Why we need the tokenizer? Because we need tokenizer in order to send the text that this model is accepting. In which model, in which format this model is accepting. In that format, if you want to send the text, then you need to load a tokenizer. So that tokenizer, how you can able to load? First, you need to create a tokenizer. So that tokenizer also the same way. You need to use the auto model, or you need to use auto tokenizer. That auto tokenizer also you need to import from here. Auto tokenizer, and you need to use that here. First, you need to load that particular auto tokenizer, particular tokenizer. Now this model related, this particular model name related model is loaded, and the tokenizer related to this model is loaded. In similar to this, if you are using any model, that model related tokenizer is there and that model is also there. So you need to load both. Then you need to specify the padding token. Why I need the padding token? In order to separate different sentences or different contexts, this model or any model use tokenizers. padding tokenizers. I am specifying that padding tokenizer as end of sequence tokenizer. From this tokenizer, whatever the tokenizer that we created, for that padding token, nothing but separating token between two sentences, we are specifying it as end of sequence token. This end of sequence token is already present in this tokenizer. Now let's understood. In this way, we need to load our model actually. So we just loaded our model. Then we also created a tokenizer and we also specified the padding separation for our tokenizer, so that our tokenizer can separate the given input based on this padding. Okay, now let's understood how to fine tune our model. To fine tune our model, first we need the data set, right? Yes, we need the data set. How can we get that data set? So in order to get that data set, you need to import load data set. You need to import this load data set function from this library. That is, from this data set library, you need to import this load data set function. Then we need to load the data set. I'm loading the data set into this variable by using this load data set. Then we need to specify the path. You can see path we need to specify at first. So where our data set actually present, or what type of data set that we are providing. Currently, I want to provide text type data set. That data set is nothing but this. You can see this is the data set I want to provide in order to fine tune my model. So since it's a text based data set, I'm providing it as text, and we need to specify the data files. So where our data files are present in the form of train, in the form of train. That is so simply understood this as I want to load a data set. So where the data set is present in this story underscore dataset dot txt, right? Yes. So that you need to provide story underscore dataset dot txt. So this data set, what I'm doing, I'm loading at where to this training to this as a training data set I'm loading, and at what path I'm loading, in this text path I'm loading. That is, in this training data set, in this text path, actually the content of this file is stored in this variable. If you want to see this, how the data will be stored, I'm just commenting the above lines, and I want to show you like how the data set is stored. Now I want to run this to show you how the data set actually stored. That is, this data set, nothing but the content present in this is stored in this variable in the form of, in training data set, in the form of, in text, this content will be stored. So within few seconds, this data set will be shown to you. You can see this is how the data set will be stored within the training data set as a text feature. Totally 9 rows data set is stored, right? Yes. So in this way, we are storing our data set. Now, okay, we loaded our data set also. I want to uncomment this. Now, what I want to tokenize this data set. Why I need to tokenize this data set, sir? Because if we not tokenize this data set, then this text formatted data is not directly accepted by our model. So in order to convert the data that is acceptable for our model, we need this tokenizer. This tokenizer will convert our data that is suitable or acceptable for model. So how can we able to tokenize this data set? To tokenize, let's say if I have a small sentence like hello, I am Spark. If you want to tokenize it, then simply we need to write like this. Tokenizer of that sentence, if we provide, then that will be tokenized simply. But what we have some lot of context. In real time, we not have only this much amount of data, we have lot of data. So in order to tokenize that much amount of data that we have in this data set variable, we need to map our data set to our tokenizer. So data set dot map, I'm mapping to what? To a lambda function. And in this data set, I want to take each and every training sentence. So for each train sentence, present in this data set, what I am doing, I want to tokenize it by using my tokenizer. So that's why I'm providing tokenizer of. So whatever the each training sentence that I'm taking, to that sentence, whatever the text I have, that text feature I'm extracting, and I'm tokenizing by using the tokenizer. And we need to truncate. If there will be any extra spaces are there, we need to do truncation as well. That's why I'm providing truncation is equals to true. And after tokenizing our data, I need to store it in a variable so that I can able to further use it. So I'm just storing it in tokenized data set. So in this tokenized data set, now actually my tokenized data is present. We just loaded our data, we just loaded our model, and after loading our model, we loaded our data set, and in order to tokenize this, we again created a tokenizer, and by using that tokenizer, we just mapping to some lambda function, so that whatever the data set we have, that data set will be tokenized. You can see each training sentence we are picking, and we are tokenizing each and every training sentences related text feature. Now we have this tokenized data set. Now we have the tokenized data set, that is we have the tokenized data set as well as our model. So what is the left? Fine tuning only, right? Yes, nothing but training. Now let's see how to train our model. So in order to train our model, we need a trainer. From where I need to get the trainer, sir? You need to get the trainer from transformers itself. From transformers, I'm importing trainer. So this trainer we need to define at first. Trainer is, so trainer of, we need to specify some parameters like which model you want to train. My model is nothing but whatever the model that I have. That is this. Whatever the model that you load, that is actually your model, not your model name. You need to provide whatever the model that you load, that is your model. Then after we have specified the model, and we also need to specify what data set, on top of what data set this model is fine-tuned or trained, right? Yes. So in order to specify the trained data set, we are specifying that by using this. This is the tokenized trained data set, right? Yes. I'm just taking this, and in this, what data I want to use for training, train data set data I want to use it for training. So that's why I provided this. Then after, we need to specify the place where to store the result. So where to store the result, that how can we able to specify? By using args parameter, we need to specify at where our data or our model output need to be stored. So here I'm specifying this args we need to specify by using training arguments. By using what? Training arguments. So this also we need to import from tokenizers itself. So that's why we imported, and we need to first create that training arguments, and we need to define that training arguments with what is the output directory. You can see the output directory I am specifying as in the current location, that is in this location itself. I want to store my model related fine-tune data in particular folder, that is, let's say, trained model. So in this trained model, directory, output directory, I want to store my data. So that's why I'm specifying it. And in this training arguments, you have multiple arguments are there. Based on your requirement, you might use one by one. Currently, since we are training our model with very few number of parameters, so that's why I'm specifying only required parameters. Here in trainer also, you have multiple parameters. If you use multiple parameters to train your model, then it is called hypervised fine tuning. Currently, I'm fine tuning our model with less number of parameters. Here I'm specifying the arguments to specify the output directory by using this training arguments. Then we need to also provide the collector, data collector, that need to collect the data from here based on the tokenizer that we specify, and that need to use this model to train our data and store the data here. So, and we also need to specify MLM, like masked language modeling or not. Now, how can we able to specify that data collector? This data collector also, we can create it by our own, or we can use the available data collector from transformers library itself. You can see on data collector, we have multiple options is there. So this is the data collector that we use for language modeling. Since we are using it for language modeling, we are using that data collator for language modeling. Here we need to specify the tokenizer. What tokenizer this data collector will use? So that tokenizer we need to specify the tokenizer that we previously defined, that I am specifying as the tokenizer. And masked language modeling. Currently, it's false in our case, because do we are training our model based on masked language modeling? That is, do we are training our model by passing a sentence and asking our model to predict whatever the content present in that mask? No. So that's why I'm specifying this as false. Then after, so okay, our trainer got created. So that's it. After trainer got created, we just need to train the model with the data set. To train, we created the trainer. First we need to create a trainer. So that's we did. Then we need to train our model. So in order to train our model, very simple, trainer dot train. So this is the command that you can use to train the model. After this command, actually your data got trained. After trained, what you need to do? You need to save the model, right? Yes, you need to save the model, and tokenizer also you need to save after fine tuning your LLM. So how to save the model as well as tokenizer? In order to save that trainer or model, to save the model, I'm using this trainer dot save model command. and I'm specifying the same location where actually my output is stored. That is in this trained model, my output got stored there itself. I'm storing this model, as well as I want to save the tokenizer as well. So I'm writing tokenizer dot save pre-trained, save pre-trained off. So where I want to store in this trained model folder itself I want to store. So this is the process. Like just we need to pick the model, then we need to get the data set that we are using to train. We need to load the data set as per our data. Currently it's a text based data, so that's why I'm loading like this directly. Then after I tokenized the data, then I created a trainer, and I'm using that trainer to train my model. My model and the data set and arguments and data collector I have specified while creating this trainer, and I'm saving the trainer at last in this folder, or you can say in this directory. Now you can see like this type of a trained model directory is not there currently till now. I'm just running this, that is I'm just running this Python code, so that after this a fine-tuned model will be saved inside this. After the whole fine-tuning got succeeded, in this folder actually the fine-tuned data, that is our model, as well as our tokenizer will be stored. So that also I will show you after the process gets completed. So let's wait for a moment so that this will be completed. I think we encountered some error. Do you mean this here? I think we did some mistake while creating this tokenizer. Tokenizer. So tokenizer dot end of sequence token that we are expecting to specify, not tokenizer. So tokenizer padding sequence is padding token is what? Tokenizer dot end of sequence. Whatever the end of sequence is there, that we are specifying as padding sequence. Now I'm just rerunning this code so that first it will pick the model and load the model into this variable. Then tokenizer related to that model is loaded into this variable. Then after we're getting the data set. After getting the data set, we again tokenized the data set. Then we created the training of our model. We created the trainer for our model. By using the trainer, we trained our model by using this command. You can see, yes. So currently it is a loading. The code is getting working. Based on the GPU or CPU that you are using, this process might take some time. Currently I'm using my local system, so that's why it is taking much more time. But in real time you are going to use cloud provided resources. Like you may use AWS provided SageMaker platform is there, so there you can use a high optimized GPU like MLM5. You can use like that multiple GPU instances you have in multiple cloud providers. So you can leverage the cloud, you can use the cloud, and you can able to use the best instance type to process faster, or you can train your model faster. Now you can see the process got completed. So totally this much runtime is taken, and these many samples per second is used to train. And the loss and epoch cycles, only 3 were considered. Since we haven't provided any epoch cycles, here we need to specify the total number of epoch cycles. But since we haven't specified anything, it was taken the default value, and the training loss is this. Okay, so like this our model is fine tuned with a very less number of parameters. Now we can even analyze the content present in this as well, and we can even use this trained model or fine tuned model in our code. Now first I want to test this model by using pipeline method. I want to test this model. How can I able to test this? So once my training got done, I'm just commenting this whole content. Now I want to test this. I want to test the model that I have created. So in order to test this, we need to create a pipeline for our model. Model related pipeline we need to create. How can I able to create this pipeline, sir? So you just need to use the pipeline function, and you need to provide the model. So what is your model? Where is your model? Currently this is the trained model that I have. So that's why I'm providing that location. And from where I need to get this pipeline? You need to get this pipeline from transformers. We have already that function available. It will create you the pipeline to this model, that is to this location. Okay, to this location, whatever the model that we have, to there pipeline got created. Now I'm just creating some text in order to test whether our fine-tuned model can able to generate the context or not. Once up on, so that's it. I want to specify only 2 words, and I want to pass this text to my model. So what is our model pipeline? So model pipeline. Now what are the response that I got? I'm from this model pipeline, I'm just storing in this response variable, and I want to print that response so that to verify whether it's working or not. Okay, I'm just rerunning this code so that currently the training method is commented, so that's why this won't work. only this will work. That is, we are using pipeline, and we are using, or we are taking the model from this folder, and then we are just asking our model to generate the text continuation to this, and we are seeing the result. Yes, you can see we might get this type of errors while fine tuning a model and using like this. We also need to specify the task type. That is currently for what task I'm using it for text generation, right? So that's why in our pipeline I am specifying my task, that is text generation. And now I'm rerunning this code so that it will use this model wherever the model that is stored inside that model it is using for this text generation, and it will take this text and then it will generate the text continuation to this. You can observe the result as well. Now I think we might not get the errors since we provided the task as well here for our fine-tuned model. Now, if you observe one point, that is we are not using any pre-trained model. We are using our fine-tuned model that is stored in this folder. You can see once upon he was silent and so forget about the result because this model is having, or this model is previously trained with less than 1 TB of parameter, 1 billion parameters. So simply remember one point: if any model that is trained with less than 1 billion parameters, then the response might be not good or not accurate. So we use models which are trained with more than 1 billion parameters because they'll provide you the responses at much better way. So now you can see this is the way where we can able to fine tune our model. Either the model may be anything that you can pick from or that you can load from Hugging Face library. This is the general way where you can able to fine tune your model with less number of training as well as training parameters, trainer parameters. In this trained model, whatever the content that we get, among this I want to specify you some more detail, like the internally how the model trained data will be stored, that I want to tell you. So first I want to uncomment this code related to fine tuning. So this is the task that we need to perform in this video that we have done. Now I want to open this model. I'm opening this in my file explorer so that to specify you in some more detail about it. Now you can observe here in this trained model in this folder, what we did, we stored our model as well as two things we stored, our model as well as the tokenizer, the two things that we stored. So if we do that, so here in this step we stored our model as well as the tokenizer, and the model related output also we stored here. So during this time what happens is it will create you the trained or fine-tuned model. So where is that model actually? This model dot save tensors. This is the actual file related to that. You can observe 474 MB. Totally it's a 474 MB. That is nothing but weights or the model related weights. After fine-tuning it, the final fine-tuned model related weights. By using these weights only, this model is predicting you the response for your given input. And this is the vocabulary. So what does this vocabulary.json indicates? This vocabulary.json indicates the vocabulary, nothing but for each and every sentence or for each and every word, what is the corresponding or how the data will be represented. That vocabulary is this. So like that in this vocabulary.json tokenizer. Tokenizer actually use this vocabulary.json file in order to tokenize our data. And so this is the vocabulary that our tokenizer will use whenever we train our model or whenever we tokenize our data by using a tokenizer. This data set will be used. And so here you have this tokenizer.json. It will provide you the tokenizer related content, like in detail about the tokenizer related data. So whatever the data it has, whatever the vocabulary it is using, so that all data will be available here. And so if you open this, then this config.json, this config.json is nothing but our model related configurations. Previously this tokenizer.json is related to our tokenizer configurations, and this config.json related to our model related configuration. So this is the model that we taken and that we fine tuned, right? Yes. So that's what here the data is specifying, and other related details also present here in this file. So basically this config.json represents our model related configurations file, and this model.save tensors represents the weights related to our final model after fine tuning. So this actually is important, and our config file is also important, and the tokenizer.json as well as the tokenizer configurations.json. So among these one is important, and this vocabulary.json is also important because actually our vocabulary present in it. Only those files are very required for us. By using only that data, we can able to further use it. Or you can say here in this M1, I just copied the required files like model.save tensors and configuration.json. This is related to model configuration, and my tokenizer related configurations I copied, and the vocabulary related JSON also I copied. Now I want to use that data. I want to use that model, only that model, without having excess files. I'm just using that model. I want to use that model whether it can able to work or not, only with those files. You can see I'm providing this here M1, and I'm just rerunning this code where this M1 folder is having only our model related safe tensors, nothing but model weights, and our model configuration file, and the tokenizer related configuration files, and the vocabulary file. Now let's see whether this can able to generate the result or not. So basically these are the important files for running any model. It may be any model. Since we fine tune our model by using Hugging Face Transformers library, it will create you this safe tensors model. In multiple ways we can able to create this weights, that is in the form of a pytorch we can able to create, in the form of safe tensors also we can able to create. You can see we got the generated output, like once upon a time in a land far away there lived a brave knights, so and so something content we got. So this is also working, right? Yes. So only these are very important, these are very required after fine tuning your model. So that is all about how to fine tune your model. If you observe the basic overview of it, then first we have loaded our model as well as the model related tokenizer, and we specified the end of sequence token or padding token to separate the sentence in the given input. While tokenizing the given input, how the sentences will be separated, so that we specified by using this padding token as end of sequence token. Then we need to fine tune the model. In order to fine tune our model, we need to get the data set right. Yes, that we loaded, and we need to tokenize that data set. Why we need to tokenize our data set? Because our model won't accept the text related data, so that's why we are converting our data set that is suitable for our model. So whatever the type of data our model is accepting, to that type our data is converting by using this tokenizer. You can see that we have did, and we created the tokenizer data. Then we need to train our model by using this tokenized data. So that's why we created a trainer. There we specified the model, training data, and the arguments to specify in which location we need to store our result, and then data related collator in order to collect the data from this training data set and do the training. We need to specify this data collator. This MLM represents masked label modeling. Do we need to train our model based on masked label modeling or not? That we also specified. Then at last we just trained our model. In real time we might have multiple parameters here in this training arguments as well as this trainer as well, based on your requirement. For validation you have validation data set you need to define here. For specifying total number of epoch cycles you need to specify the epoch cycles, and multiple much more details are there that you can specify while hyper tuning your model. But currently we are fine tuning our model with very less number of parameters, so that's why we specified very less. Okay, now we just used this train function by using this trainer, so that our model got trained, and at last we store our model in this folder. After storing our model in this folder, you can see this is how the data will be, and the number of runs, number of fine tunings are also stored here in this, and the checkpoints, how many checkpoints are created, those related data also stored. After getting the result, we are storing our model as well as the tokenizer, right? Yes. So in this result also we need this safe tensors, because here actually our weights related to our model is stored. Further, after utilizing this model, these weights are responsible for generating the result. So that's why this model.safe tensors are important. And to specify the model configurations, we need this config file. And to specify tokenizer configurations, we need this tokenizer.json as well as tokenizer config file. And we need this vocab.json in order to specify the vocabulary, or vocabulary that this tokenizer is actually used while tokenizing the given input. So this is the simple way of how to fine tune an LLM with a very less number of parameters. So I hope you understood how to fine tune an LLM, that is a GPT-2 from OpenAI, by using Hugging Face Transformers. From this video, I hope you understood how to fine tune any model, any general model. And this is the way. I hope you understood this video, and I feel this video is useful. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye.